Okay, the next part of this topic on series is to find the sum of an arithmetic series. So the last lesson you looked at the nth term, Tn, represents the nth term in an arithmetic series. So now we're looking at Sn, where S is the sum of n terms. And the first formula that we're going to look at is actually this one here. The sum of n terms is n on 2 multiplied by 2a plus n minus 1 times d. And you saw at the beginning of the last video that you need to know the proof for where this formula comes from. So just going through the proof over here now. So let the last or nth term be L. So we've got the sum of n terms is A, is the first term, A plus D is the second term, A plus 2D is the third term, all the way up to the last term. Then, if we were to rewrite this formula again but in reverse, you can see then that the last term is first, and then the term before that would be L minus D, the term before that would be L minus 2D, all the way down till you get to the first term. Now if you were to add these two equations together, you would get two lots of the sum of n terms, and then you can see that these all become in pairs. A plus L, that's another A plus L, because D minus D is 0. There's another A plus L, all the way down to the last A plus L. So we have A plus L multiple times. How many lots of A plus L do we have? Well, we have n lots of A plus L. Because remember, L was the nth term. Okay, so we've got n lots of A plus L, which we can write like that. And then we can just divide both sides by 2. And we get the sum of n terms is n on 2 times A plus L. Oh, sorry, actually that was the formula for the this first formula here. The sum of n terms is n on 2 lots of A plus L, where L is the last term. Alright. Oops. Okay, so then we'll go through the proof then for this second formula then. And we're just going to let L, the last term, be the nth term, which you know from the last lesson is A plus n minus 1 times D. So just substituting that into our new formula that we just found. So this is the formula, oops, that's the formula we just found there. And we're going to substitute L equals A plus n minus 1D for this L here. And substituting that in, you get this. And then just collecting like terms, that A plus A becomes 2A. And there we have the new formula for the sum of n terms. So it's n on 2, 2A plus n minus 1 times D. So depending on what information you're given in the question, if you're given the last term, you know how many terms there are, then probably this formula will be the easiest one to use, especially if you know the first term, the number of terms, and the last term. But if you don't know what the last term is, if you know just the number of terms, the first term and the common difference, then you can use this other formula here to add up the sum of all of the terms in that series. Examples using those formulas. So the first example says find the sum of the first 25 terms of this series. So 25 there is n. Okay, and you can see the first term is 6. And what else do we have? The common difference is 10 minus 6, which is 4. And we just said before that n is 25. So using our formula, we want to find the sum of 25 terms, which is given the notation S with a little subscript 25. So we do not have the last term there, so we're going to use the formula n on, I'll just write the formula up here again. S of n terms, sum of n terms is n on 2 brackets 2a plus n minus 1 lots of d. So substituting into that formula, the sum of 25 is equal to 25 on 2. 2 times a, so that's 12, plus n minus 1, which is 24, times d, which is 4. Okay, so just a simple substitution into the formula. So that's why it's really important that you memorise this formula. And then you get the sum of 25 terms is 1,350. Alright, the second term, evaluate the sum of this series, where the first term you can see is 9. A is 9. What else can you see? What is the common difference? 14 minus 9, or 19 minus 14. So you can see the common difference there is going to be 5. And this time we're given the last term. The last term is 494. So L is 494. But we don't know what N is. What term is 494? What is N? What term is that in the series? So we're going to have to use the formula for the nth term of an arithmetic series, Tn equals A plus n minus 1 times D, to find what n is. So substituting in there, the nth term is 494, A is 9, n minus 1 is what we want to find n, but we got D is 5. So we can subtract 9 from both sides. We can then divide both sides by 5. And then we can plus 1 to both sides. That means the last term, the 494, represents the 98th term. So we want to find the sum of these 98 terms. Okay, and we can use which formula? Well, we've got the last term there, so we can use the other formula. Right, the sum of n terms is equal to n on 2 times A plus L. So we'll use that formula there. Sum of 98 is going to be 98 on 2 times by A, which is 9, plus the last term, which is 494. The sum of 98 terms there ends up being 24,647. Alright, then let's have a look at number 3. How many terms of this series, 6 plus 8 plus 10, give a sum of 2,064? Alright, so you can see that the first term, A, is 6. The common difference there is either, you can see, is 10 minus 8 or 8 minus 6, which is 2. We know the sum of these n terms is 2,064. We don't know what n is. That's what it's asking us to find. It's asking us to find what n is. So we've got A, D, and n, so it means we need to use this formula here to solve this for n, because we don't know what the last term is. So substituting in there and solving for n, we're going to have 2,064 equals n on 2, 2a, which is 12, plus 2 lots of n minus 1. Okay, so just move the d to the front of those brackets there. Let's multiply both sides by 2 to get rid of the fraction there. So 4,128 equals n lots of 12 plus 2n minus 2. So what's that? 12 minus 2 is 10. And then let's maybe expand the brackets, and I might put the n squared term first, then the 10n, and then we'll minus the 4,128. Oh, sorry, that's going off the page a little bit. So it's 4128 here, but we subtracted that, so that becomes 0. So now we've got a quadratic to solve. Let's divide everything by 2 to make it a little bit easier. N squared plus 5n minus 2,064. We times it by 2 before. Alright, so we're looking for two numbers whose product is 2,064, or negative 2,064, and whose sum is 5. Well, I don't know what that is off the top of my head, so we can't factorise it, so maybe we'll just use the quadratic formula. So n is going to be negative b plus or minus the square root of b squared minus 4ac all over 2a. Alright, so we ended up with two solutions, either 43 or negative 48. But remember what n represents. N is the number of the term. So we can't have, so n's got to be an integer. They're both integers, but we can't have a negative 48th term. It's going to start at 1, the first term. The second term is n equals 2. So n has got to be greater than 0. So that means n equals 43. So that means we got 43 terms in this series that have a sum of 2064. Okay, next example. The sum of the first 5 terms of an arithmetic series is 20. So that means sum of 5 equals 20. And then it says the 8th term is 19. So that means T8 equals 19. Alright, find the values of A and D. So let's put in some more information here, what we know for the sum of 5 terms, an expression for that, and also an expression for the 8th term. So if the sum of 5 terms is equal to 20, then you know that that's going to be n on 2. And what do we have? A plus n minus 1 times d, no, 2a plus n minus 1d, or we could say 2a, a plus l, but we don't have the last term there, so we might have to just leave that as 2a plus n minus 1 times d. But we have n, so it's 2a plus n minus 1, well n is 5, so it's going to be 4d. And then for the 8th term, it's going to be a plus n minus 1, which is 7d. So now we have two equations and two variables. Ooh, this n here, we should have replaced that with n, which was 5. Let's see if we can do that. No, we might have to erase the whole thing. Oh, let's see if we can go over it in white pen. Yes. And then we'll go over it in red pen. Alright, now that's better. Now we have two equations with two variables, a and d, a and d. So, how do you solve two equations with two variables? That's right, simultaneous equations. So, this first one, what's really that one there? Let's make a the subject there. Then we'll make a the subject in this other equation, then we'll make them equal to each other. So, in that first equation, let's make a the subject. We'll multiply both sides by 2. And we'll also divide both sides by 5. And we'll subtract 4d. And we will divide by 2. And in this other equation here, to make a the subject, I think that's pretty obvious, that a equals 19 minus 7d. So we can say 4 minus 2d equals 19 minus 7d, because they're both equal to a. And then let's solve this equation. So plus 7d to both sides, minus 4 from both sides, divide both sides by 5. There we have d, and now we find a by substituting into either 19 minus 7d or 4 minus 2d. So 4 minus 2d, so 4 minus 6 is negative 2. Likewise, if we'd substituted into here, 19 minus 21 is also negative 2. So there we've answered part A, find the values of A and D. Alright, there's A. Oops, sorry, that's D. And then there's A. Alright, part B, find the sum of the first 50 terms of the series. So it's asking us to find S50, sum of 50. And we are going to use the formula that we know for the sum of n terms, which is n on 2 lots of 2a plus n minus 1 times d. So after you write that down a couple of times, it gets a bit easier to remember. So sum of 50 is going to be 50 on 2, which is 25. Lots of 2a, remember a is negative 2, so times 2 is negative 4, plus n minus 1, so it's 49, times d, which is 3. Okay, so the sum of 50 terms of this series is going to be 3,575. Okay. The sum of the first 20 terms of an arithmetic series is 138, and the sum of the first 19 terms is 125. Find the 20th term of the series. Now we're going to do that, and there's a couple of ways that you could do this, but there's another little formula here. So I'll explain where this comes from to show you a quicker way of working this out. So we've got, say, T1, T2, T3, T4, all the way up to T19 and T20. Now, the sum of the first 19 terms, it says, is 125. And then it said the sum of the first 20 terms, so from there to there, is 138. Find the 20th term of the series. So this question is asking us to find T20. Find the 20th term. So what is this 20th term? Well, if you can see from this diagram here that the sum of the first 20 terms is 138. The sum of the first 19 terms is 125. So if you were to add on the 20th term to the sum of those of the first 19 terms, then you would get the sum of the first 20 terms. So that's why T20 is equal to the sum of the 20 minus the sum of 19, which is what this formula here is. So we can say T20 equals 138 minus 125, which is 13. So the 20th term is 13. Pretty cool. That's